Hello and welcome back to the next session, gain of travel wave tube amplifier, or we can call this as gain consideration of what you call as your travel wave 1 minute travel wave tube amplifier. Okay, we can continue with this one. So if the structure is perfectly matched, then then there will be no backward traveling wave. That is, if there is a backward wave from the output to input, so in order to minimize the backward wave, normally we are keeping the attenuator at the center of the traveling wave tube. Okay, so I'll try to take that one, that is gain consideration. Sorry. The structure should be perfectly matched. Okay, structure is perfectly matched so that there is no backward traveling wave. Backward traveling wave. Okay, that is, if there is, even if there is backward wave, if there is backward wave from output to input, then in order to minimize backward wave, what we are keeping, an attenuator is kept at the center of the of TWT, that you know. Okay, so the total circuit voltage what is that, is the sum of three forward voltages. Voltage. Okay, or three forward traveling wave, we can call this traveling wave. This is equivalent to V of z is nothing but V1 e raised to minus gamma 1 offset plus V2 e raised to minus gamma 2 offset plus V3 e raised to minus gamma 3 offset. Okay, so which in general I can write as sigma n equal to 1 to 3 Vn e raised to minus gamma n offset. Okay, Vn e raised to minus gamma n of set. And conventional current, you know, conventional current is given by, that is, I is nothing but j beta I naught divided by 2 V naught j beta e minus gamma the whole square into E1. Okay, that already you know. Is it? You take take what? E1 equal to gamma into V, and gamma is nothing but j beta I into 1 minus C into delta. Okay, and assume C delta is very much less than 1. You call this equation 1, you call this as equation number 2. Okay, so you substitute equation 1 in I, and also 2 in I. You know, the values of I is this one. Okay, this is I. Okay, what you will get? Once you substitute equation 1 in I, you will get j beta E I naught divided by 2 V naught j beta E minus gamma whole square into gamma into V. That is E1 is nothing but gamma into V. Similarly, once you give 2 in I, that what you will get? I is nothing but j beta E I naught divided by 2 V naught j beta E minus what is the gamma we have to change, that is j beta into 1 minus C into delta square into j beta into 1 minus C into delta into V. Okay, so that changes to I is nothing but j into j is nothing but j square beta E square 1 minus C into delta V into I naught divided by 2 V naught into j beta E minus j beta E minus minus and minus into plus j beta E C delta square. Okay, so what happens? J square is nothing but minus 1. So I can write I is nothing but j square this and this get cancelled, so it will be j square beta E square 1 minus C into delta V into I naught divided by square of this one j square beta E square C square delta square to V naught. This and this cancel, this and this cancel. Okay, so and C into delta we are taking is very much 1, so neglect less than 1, so you neglect it. So you will have I is nothing but I naught by 2 into V naught into V by C square. In general, you can call it as delta N square. Call it as equation A, that is I. Okay, clear? You put V of Z in equation A. What is V of Z? Is that sigma n equal to 1 to 3 Vn e raised to minus gamma n into Z, the first equation. So you have I of Z is nothing but I have put minus sign here because minus sign is in this is a minus z direction. Sigma n equal to 1 to 3 I naught by 2 V naught Vn by C square delta n square e raised to minus gamma n into Z. Call it as equation B. This minus sign is in minus Z direction. I just put that one. Okay, now to see that this is in the minus Z direction. Okay. So from the derivation of conventional current, uh, we have obtained one equation. From the derivation of, just verify that one, okay, conventional current, we had obtained the equation that is V1 is nothing but minus E by M E1 j omega minus gamma into V naught. Call it as equation number 3. Okay. So I will put E1 is equal to gamma into V. Gamma is nothing but J beta E into 1 minus C into delta. Okay. V naught is nothing but root of 2 E V naught by M. Beta E V naught is nothing but omega. Okay. And C into delta is very much less than 1. Substitute all these things. E1 is equal to gamma into V, J, gamma is nothing but J beta into 1 minus C into delta. V naught is equal to root of 2 E V naught by M. Beta E into V naught is equal to omega. C delta very much less than 1. Substitute all above equation in 3. You get V1 offset. V1 offset can be written as sigma n equal to 1 to 3 J V naught by 2 V naught C Vn by delta n e raised to minus gamma n into Z, called the equation number C. Okay. And the three equation becomes V of Z is that, but the three equation what you are getting is V of Z is equal to sigma n equal to 1 to the 3 gamma n e raised to minus gamma n into Z, and other one is I of Z is at minus sigma 1 to 3 I naught by 2 V naught into C square Vn divided by delta n square e raised minus gamma into Z, and V1 of Z is the but sigma n equal to 1 to 3 J V naught by 2 V naught into C Vn by delta n e raised minus gamma n into Z. These are the three equations that we obtained. Okay. The three equations we obtained. Okay. It is a lengthy process. That's so to determine amplification of growing wave, the reference input point is set at z equal to 0, and output reference point is taken at z equal to L, that is L is the particular length. Okay, so it follows that at z equal to 0 voltage current and what you call as your velocity, and velocity at input point is given by, that is for z equal to 0, v of 0 is nothing but v1 plus v2 plus v3. I call this equation 1. Okay, and I of 0 is the minus I naught by 2 v naught c square, v1 by delta 1 square plus v2 by delta 2 square plus v3 by delta 3 square. Call it as 2, and v1 of 0 is nothing but minus j v naught by 2 v naught into c is not this 1 meter. This is this 2 v naught are different. Okay, one I will write it as small, v naught into c into v1 by delta 1 square plus v2 by delta 2 square plus v3 by delta 3 square. Call this as equation number 3. Okay, so from 1, 2 and 3, 1, 2 and 3, at I equal to 0 and v1 of 0 equal to 0, you will get solution is nothing but v1 equal to v2 equal to v3 equal to v of 0 by 3. Call this equation 4. Okay, so the growing wave increases exponentially with the distance. So the growing wave increases exponentially with the distance. Okay, so I can write therefore v of L is nothing but v1 e raised to minus gamma 1 into L. Gamma 1 is nothing but minus beta e c root 3 by 2 plus j beta e 1 minus c by 2. Call this equation number 5. Okay, and v of L, v1 of L, v of 0 by 3 exponential of root 3 by 2 beta e c L into exponential of minus j beta e 1 minus c by 2 into L. Okay, and that is v1 of L, which is equal to v of 0 by 3 exponential of root 3 by 2 beta ECL exponential of minus j 1 minus c by 2, so c by 2 into L. Okay, c by 2 into c by 2 into beta into L. Okay, call it as equation 6. Take beta into L is the 2 pi n, where n is the circuit length of the electronic wavelength. Of the electronic wavelength, that is n equal to L by lambda into E. Okay, therefore beta into L is nothing but 2 pi L by lambda into E, which implies beta is nothing but 2 pi by lambda e. Okay, so equation 6 becomes v of L is nothing but v of 3 v naught v of 0 of 3 exponential of root 3 c pi by lambda into e exponential of minus j 1 minus c by 2 2 pi by lambda into e. Okay, so this term is somewhat nearly equal to 1. So this term I can call this 2 pi n. Okay, so or I can write v of L is nothing but v of 0 by 3 exponential of root 3 c pi by c pi n. Okay, so this is equation for v of L, and the power gain in dB implies AP is nothing but 10 log of v of L by v of 0 whole square, which is nothing but minus 9.54 plus 47.3 NC. I think it is 40.3 NC. Okay, this is the power gain of traveling wave tube amplifier. So where NC is the numerical number, where n is the what we called as electron wavelength of slow wave structure, C gain parameter. Okay, C is the gain parameter. So one more small point I will write. This indicate the equation or the equation for IP. Equation for AP indicates an initial loss at circuit input of 9 point how much initial loss of circuit 9.54. Okay, 9.54 dB. So this loss result from fact of input voltage split into 3 waves of equal magnitude of equal magnitude. My stylus is stuck. Three waves of equal magnitude, and the growing wave voltage is only 1/3 of the total input voltage. Okay. So your power gain will be proportional to the NC, that is a numerical number. Just a second, system is hanged. equal, yes, okay. Sorry, system hand, just a second, of equal magnitude and the growing wave voltage is only 1/3 of total input voltage. Okay, so the power gain is proportional to NC. Okay, this is the thing what I had to explain to you regarding the what you called as okay, so this is the final conclusion. Okay, important. So I will give you one problem related to traveling V2. After that we can close this one. One numerical problem. Okay, that is a TWT operates under the following parameter. Okay, beam voltage V naught is equal to 3 kilovolt. Beam current I naught is equal to 30 milliampere. Characteristic impedance of helix Z naught equal to 10 ohm. Okay, circuit length N equal to 50. Frequency F equal to 10 gigahertz. Okay, you have to determine A, the gain parameter C, B, the output power, the output power gain AP in dB, and C, all 4 propagation constant. All 4 propagation constant. Okay, so I will write the solution for this one. First, A, gain parameter, you know the equations, that is C is nothing but I naught is not by 4 V naught raised to 1 by 3, which is nothing but 30 into 10 raised to minus 3 into 10 divided by 4 into 3 into 10 raised to minus 3. What is V naught? 30. It is plus 3. Okay. So that is nearly 2.92 into 10 raised to minus 2 gain parameter. B, the output power gain is AP is nothing but minus 9.54 plus 47.3 NC, which is nothing but minus 9.54 plus 47.3 into 50 into 2.92 into 10 raised to minus 2. that is equal to 59.52, and all the 4 propagation constant. Third one is the 4 propagation constant, okay, for that beta E omega by V naught, which is nothing but 2 pi into 10 raised to 10 f. F is nothing but 10 gigahertz, okay. Divided by V naught is nothing but 0.5. I will write 0.593 into 10 raised to 6 to root of 3 into 10. Okay, that is V naught, which is nothing but 1.93 into 10 raised to 3 radian per meter. So gamma 1 is nothing but minus beta E C root 3 by 2 plus j beta E into 1 plus C by 2 is the minus 1.93 10 cube 2.92 into 10 raised to minus 2 into 87 plus j 1.93 into 10 raised to 3 into 1 plus 2.92 into 10 raised to minus 2 divided by 2. You will get somewhere minus 49.03 plus j 1952. And gamma 2, in a similar manner you calculate gamma 2 also, that is beta I C into root 3 by 2 plus j beta E 1 plus C by 2, that will be nearly 49.03 plus j 1952. And V3 j beta I into 1 minus C, which is nothing but j beta is nothing but 1.93 into 10 cube 1 minus 2.92 into 10 raised to minus 2, which is nearly j 1872.25. And finally gamma 4 minus j beta I 1 minus C cube by 4, it is nothing but minus j 1.93 into 10 cube 1 minus 2.92 into 10 raised to minus 2 the whole cube divided by 4. So that is a minus j 1930. So this is something regarding a direct problem only related to traveling wave tube amplifier. So I am stopping here. All the things I have taken related to the traveling wave tube amplifier. Better to refer this notes only, because in textbook you cannot be able to understand, because they have marked most of the equations in the derivation. Okay, so the next video lecture onwards we can see. We are stopping here all the tubes related to your syllabus. The next video lecture we will come across with some of the measurement of microwave devices. Thank you.